Before we start, how many people here are developers? How many people are security people? One. Okay. Two. Oh, good. SRE. Have we got any ops people here or SRE? We've got a couple. Okay, cool. This is like just going to be introductory to Kubernetes security. So we're not going to get too deep, but from the application developer point of view or SRE, there's some good points in here. If you want to talk about anything deeper, just come and see me after. So basically, I am Scott Coulton. I've worked for Microsoft for about 6 months now. Prior to that, I worked at Puppet on their cloud native play. I spent the last 4+ years developing in Golang on any of the container-related like bits and pieces, whether it be Containerd, Linux Kit, a whole heap of stuff like that. Now I'm moving more towards Rust. So some of the security stuff is like, hey, just run it in Scratch, which is really easy if you run a compiled language and stuff like that. But yeah, that's me. Follow me on Twitter and things like that. So what we're going to cover today, because this is a 101 course, is the architecture of Kubernetes to start with. Most people that when I talk to about security, or just in Kubernetes in general, don't understand the services within Kubernetes itself. And it's probably super important. I'm going to be talking about upstream Kubernetes now, so this is not Azure specific. And I'll also talk about like AWS and GKE as well, if you've got a managed service, what they support. And then we'll get into the security stuff, so like how to secure some of the basic component security, pod security, RBAC. A lot of people, like I've spoken to customers that have gone, oh, I turned RBAC off because I couldn't get my application to work. And then I say to them, well, in the olden days, you had firewalls. If your application couldn't talk, did you disable the firewall? And they usually say no, and I'd say, well, it's kind of like the same thing. We'll look at how to automate it as a developer, and then what we're going to do is we're actually, if we've got time, we're going to actually look at a Docker file. I've got a deployment running with my fake company website. We're going to then like hack it and deface it, and then look at why we could do that. And if anyone in the audience, their answers are actually here in the talk, and it's going to be interactive at the end. If you want to have a look at any of the code examples on here, this is a workshop that I've done for Azure. But you can port the stuff across to any other cloud vendor actually, except for the install of Kubernetes. So Kubernetes architecture is pretty straightforward. There's a master node and a worker node. So it's broken down into 2 node types. If you host it in a hosted environment on the cloud, you actually won't see the master nodes. So whether it be AWS, us, or GKE, they actually manage the master nodes for you. You just look after the worker nodes. The master node is responsible for the control plane and the security controls. That's probably what we most want to hear about today. And worker node is pretty straightforward, running workloads. There is some work being done in the Kubernetes ecosystem at the moment to totally get rid of worker nodes. And that project's called Virtual Kubelet. What that will actually allow us to do is you'll just have a Kubernetes API and a control plane, and then it'll be backed onto another service. For us, it's ACI. For AWS, it's Fargate. And Google's got Run now. So there's a whole work in the Kubernetes ecosystem to take the responsibility of like worker nodes off the end user. So you don't have to worry about security controls or patching or any of that sort of mundane tasks on the worker node side. That's a nirvana at the moment. In the Virtual Kubelet project, there's some limitations to networking around the stack. It is being worked on. It's going to be a lot better. If you listen to the KubeCon announcements next week, there'll be some stuff around Virtual Kubelet there. But this is the most important thing. Whether you run a hosted service, or you run Rancher, or you run upstream Kubernetes, you should actually know what all these components do. And these are distributed components, and it's not easy to find out if you're new to Kubernetes what's gone wrong, especially on the security side, between any of these components. So these main components are the API server, which is the entry point for kubectl or kubectl, whichever you like to use. etcd is important. That's the brains of Kubernetes itself. We'll talk about the scheduler, controller manager. And Cloud Controller Manager is actually important from a security point of view. This is the interface where Kubernetes has permissions to your cloud and then can provision like storage, IP addresses, load balancers, and everything on behalf of you as a user. So if you don't have that secured properly, you can create rogue services. So we'll talk about that a little bit. A lot of people don't look at that hard enough and give their cluster like admin role to their cloud. So we'll just have a look at some controls you can put around that. And on the worker nodes, there's just kubelet and kubeproxy. It's kind of confusing. These are actually on the control plane as well, because everything in Kubernetes runs on a container except kubelet itself. So that you'll see these on the control plane as well. The Kube API server, this is probably the most important things to secure. One of the things that has been tightened up now, but was available a while back, was anonymous login on the Kubernetes API server. And the dashboard actually used that. How many people remember Tesla left their dashboard open to the internet? Yeah, that was kind of not good. So if you're on a cloud-hosted server, this is pretty much secured for you. If you're spinning up it yourself, though, you really need to know that this is the entry point for the cluster. This is where validation's done, and it's a REST service, so you can hit it from anywhere. There's actually a Metasploit plugin on GitHub that looks for open Kubernetes clusters. So I suppose we've got popular enough now that someone's gone, hey, I'll write a Metasploit plugin to search the internet for open Kubernetes clusters. So there is a risk there. etcd, this is an interesting one. This is where all the sensitive data for the Kubernetes cluster is. So if you've actually been broken into and they want to do reconnaissance about where everything is, this is where they'll try to get into. They'll be able to find out all the pods where they're running, the pod names and everything else like that. If this is not secured properly, it's bad. If you have a look at the key infrastructure for Kubernetes, you should split out the CA. So the front end's got its own CA, so if it gets compromised, etcd should have its own CA, so it should be compromised, and then the backend services need to have their own CA. Now, if you're on the cloud, again, this is all done for you. If you use something like Rancher, I think that they do that for you as well. Also, if you use kubeadm, this will spin this all up for you as well. Which is really good for like initial security, but if anyone's ever tried to do key rotation on a Kubernetes cluster in production, it's like, because you've got so many CAs, you've got to replace them at the right time. It kind of reminds me back of the day when I was a sysadmin and there was that really old RAID controller and a disk died, and you pulled it out and you're going to change it and you're like, oh, is this going to go well? It's like 50-50, it's out of your hands at that point. If you've never done that before, I've written scripts to do it and actually update Kubernetes certificates, and like it still fails like 2 out of 10 times because it's not done in the right order, or if one step fails. So the cloud's got a whole heap of stuff built to do this. I know Amazon handles this, GKE handles it, and so do we. But yeah, if the certificate infrastructure is super important, and protecting etcd is super important. Because the certificate infrastructure was so hard back in the day, people actually would just allow etcd to be like open, and then what they would do is they would secure the network around it. But if someone got onto a node, even a worker node that should be least privileged, actually could hit etcd because there was no security controls around it. It was just like you could just curl to it, and once you found it, you could find out where everything else is. So etcd is like super important to protect. It's your key value store. It has got some limitations from like, I think Atlassian found it actually. It only holds a 2 gig database, which is about 80,000 namespaces and RBAC roles before the cluster starts going a bit weird. I think when they come up with etcd, they thought 2 gigs worth of key value stores. That's a lot of key values, like for 2 gigs, when you think how big a key value is. There's some work in the Kubernetes ecosystem to fix etcd at the moment. I know from what I can talk about in Azure, we're actually built an API for Cosmos DB that makes Kubernetes think Cosmos DB is etcd. Then we can like have bigger database size, lower latency, and a few bits and pieces like that. I know Google's working on a similar thing. I'm not sure about Amazon. But yeah, that would also, externalizing etcd out of the cluster will actually should improve security because you're moving the concern out into a different service of where everything lies. Kubescheduler, this is just watches for new node assignments. This is important to know about if, in case like things are joining your cluster and you're like, well, auto-scaling groups and things like that to make sure that there's no rogue nodes joining your Kubernetes cluster. And it also looks after like things like Infinity. So if you have like disks or services that need to be segregated and to run only on certain nodes, then Kube Scheduler is what looks after that. Controller Manager is node up and down, and it's a replication controller. So we'll talk about pod spec in a little bit. Doesn't look after pod spec. It just looks after the replication, so the desired state of what your application needs. So if you do a deployment and you say you need 3 of the pod running, that's the replication controller that looks after it. Kubelet and the pod spec looks after the individual pods themselves, so it's at a high level. But what's really important with the controller manager is it looks after the default accounts for the namespaces and API tokens and the secrets. So that's probably what you want from a security point of view. Look at the logs of controller manager to see the default tokens being leased for the namespaces of the applications. We'll speak a little bit more about namespaces in a minute. But yeah, so all the API accounts inside namespaces and RBAC roles, the service tokens get leased from control manager. As I spoke about a little bit earlier, Cloud Control Manager, this is what acts on behalf of the user to automate cloud services from Kubernetes. So whenever you type expose service -- type load balancer in the cloud, whether it be GKE, Azure, or Amazon, it'll actually go out, hit a cloud API, create a resource, create an IP address, could possibly update a public DNS record, and then have your ingress. So just be careful what you've got here, because there's 2 things that can happen. One exploit that can happen is that someone can set up an ingress rule with the same ingress name as one that's already pre-existing. That second ingress then can steal the data going out and in and out of the first ingress point. So if you use something like Open Policy Agent, you can actually check to make sure you don't have 2 ingress URLs that are the same. Kubernetes will actually allow you to do it at the moment. And what happens is the rogue ingress point can start doing like a man-in-the-middle sniffing and get the data from going out of the other ingress point. So the Cloud Controller Manager, like if someone gets on there and is able to spin up things like this, that's what they'll be able to do. So it's just important to make sure your IAM roles or your service principal, or I forget what GKE is set to the right privileges only to be able to provision what you need, not just give it access to admin. Kubelet is responsible for running a pod. That sounds weird because it just makes sure that the pod is up or down. It can't restart, it can't do anything like that. And it just takes the pod spec, which is the JSON representation of the YAML file that you give it. And as I said, it just like pretty much focuses on is it healthy, is it not? And it's the controller manager that does the restarting and the self-healing in Kubernetes. This is important as well, kube proxy. So I watched a really interesting talk from Netflix at DockerCon. They actually disable this. So instead of having like kube exec available to any of their pods, they actually run an SSH daemon inside each of the containers and then have another service that does all the leasing of the keys and a whole heap of stuff around it. Because they found that this was not as secure as that. So just be aware that you can stream through kube proxy. So anything that does kube exec and things like that can be used, and it can be disabled in Kubernetes if you don't want it to. And as I said, Netflix disabled it. The talk's online. It was actually a really good talk. It was interesting to see Netflix's approach to container security. This is really important as well. How many people know out of the box the different security controls that come depending on the Kubernetes runtime you have? So out of the box, if you use Docker or Moby, before I go on, how many people know what Moby is? Okay, just a few. So Moby is the open source components of Docker. So for example, we use Moby at Azure because we can't put Docker CE into AKS and then resell it as against Docker's licensing agreement. So but what Docker does allow us to do is take all the bits that make up Docker and compile it ourselves, and we have Moby, which is the same as upstream Docker, but that's not against their licensing agreement. Then you've got Containerd and you've got the Crow project coming out of Red Hat. So straight out of the box, if you use Docker or Moby, you'll get a default seccomp profile, you get a default AppArmor profile, and a default SE Linux profile that can be passed up to Kubernetes itself. If you choose Containerd, that's not there. It has got the hooks to add setcomp and everything in there, but no profiles are shipped by default with Containerd, and Crow only supports SE Linux. So straight out of the box, the underlying security that you can pass up to from the kernel to Kubernetes is different depending on the runtime you choose. Most people, when you talk to them about this, it's like a religious discussion about, oh, like I don't want to use Docker, or I don't want to use Containerd or this and that. But when you go, well, besides like that, what about the security profile of your cluster? Have you thought about this? A lot of people are not thinking about that when they make a decision about runtime. So like, for example, we can pass up setcomp profile, default or a custom one, up to the pods through the interface in Moby in Azure. If we use Containerd, we could do the same, but it means a customer wouldn't get the default one out of the box. And I don't know a lot of customers that like to write setcomp or SE Linux profiles, so a lot of people just use the default one. This is just a sample of what Kubernetes looks like before you actually put application traffic on it. So as you can see there, it is complex. I've seen a really good tweet here about a month ago now that someone said to Kelsey Hightower, you've got a repo on GitHub called Kubernetes the hard way. That assumes there's an easy way. And to be quite honest, it is difficult. There's a lot of moving parts to it. And from a security point of view, it's a distributed application, and if you don't have the right tracing nor logging, it can be quite difficult to find out what's happening in your cluster if you're spinning it, especially if you're like spinning your own up from scratch. There can be a lot going on there. So now we'll get to actually securing some of the components and look at best practices. These are some defaults that are in Kubernetes upstream. So if you just like spin it up with the scripts and bits and pieces in the GitHub repo, these are all set to default. Now, if you're running Rancher or you're running AKS or you're running GKE or EKS, or Docker's got DKS now, so the Docker Kubernetes service, these defaults are different, but I just wanted to go with upstream, so there's a disclaimer there. So these are the pots you need. So when you've got worker nodes, a lot of people that I see when I look at their cloud implementations don't have any security groups around the worker nodes. They just have a pod of worker nodes there, and then they're open to pretty much the control plane. It'd probably be best to lock that down like you would anywhere else in the world. So security in Kubernetes, I'm not going to say it was an afterthought, but there was such a push to get functionality out there. Security really didn't come into 1.6 when RBAC came in. And some of the defaults that are still there around authorization mode, insecure port, and using certificates is a bit patchy. And then we'll talk about the emission controller. Before I go on, how many people know what the emission controller is? One? Okay, cool. We'll talk about what the emission controller is. This is actually a really good bit of tech, probably one of the best things in Kubernetes, actually. So if you have a look at what Kubernetes will spin up if you don't put kubelet flags in and you just do upstream, you'll have anonymous auth equal true if you disable RBAC. And so that basically that means if anyone has the endpoint of the API server and has a kubectl and just points it there and they know the URL, they can hit it. So just be aware of that when you're setting up Kubernetes, if you're setting it up yourself. If you're using one of the clouds, like for our example, our workflow is if you disable RBAC on the flag for spinning up the AKS cluster, it'll put certificates in place and just disable RBAC. I still don't think you should disable RBAC, but yeah, just be wary if you're spinning this up yourself. Anonymous auth equals true would be horrible. And as we'll go into in the end, last bit, these are all systemd files. So they should be deployed by some mechanism of CD, hopefully. And you can check for these in the build process of those systemd files. The other thing is insecure port. So if Kubernetes doesn't find certificates, when you start the API server, insecure port will be enabled. So that just means that it's all the traffic for your clusters going over HTTP, which is not real good because everything's passed in JSON. I believe it's base 64 encoded, but that's not really secure in any form of the imagination. So what I've seen some people do is like they still use 6443 but it's still insecure. It's not HTTPS. They've just changed the port. So what you might want to do on your kubelet flag, on the kube API flag, sorry, is set insecure port to 0, which means it's turned off. So it has to use HTTPS traffic. Running kube API without the certificates is not recommended. So here's the security configuration just for Kubernetes API. So you can see there you've got the CA, the service key, and that. So it's nothing like too out of the box there. But what I will show you is I'll go to GitHub and actually go to here and go to this is a printout of kubeadm deploying a cluster. So you can see the certificates here. So that was the certificates for kube API. You can see here that it's generating the API server, service account, public key, front proxy CA, etcd server for DN, and it goes on and on about all the certificates that it needs. So that's what I was talking about. The replacement of the certificates and the infrastructure that's needed to run Kubernetes is actually quite hard. But you can check to make sure it's there. And just for your own knowledge, if you want to check where they are, they're on the etc Kubernetes manifest. Certs is where the cert location is. But as you can see, there's a whole heap of certs there. I think there's something around a span of like 9 or 10, with I think 3 CAs. When I was working at Puppet in my previous job, we built an OS that ran Kubernetes from scratch, and the certificate infrastructure provisioning time was like the biggest challenge we had, because we didn't want to ship it without the certificates. And then the upgrading of the certificates was the second biggest challenge we had. But yeah, so again, you should use 509 certificates. If you use any of the clouds, this is on by default. If you use kubeadm, it's on by default. I think Minikube now, it's on by default as well. But if you spin it up from upstream, there's no certificate support. Kubernetes has an ethos that like configurations around security and stuff, there's interfaces there for it all, but it's up to the implementation of the provider to implement security controls, whether it be like Microsoft, Amazon, Google, Rancher, whoever's like packaging up the Kubernetes cluster for you. A mission controller, so I'll step back a little bit and explain what this is. There's actually a hook in Kubernetes that makes sure any call is authorized before it actually executes, and that's called the admission controller. So what happens is if you make a call to a pod or you make a call to etcd, the admission controller actually sits there and makes sure that you're authorized to make that call before you get to the actual endpoint of the service. The problem with the admission controller is that it's by default is like set to very low. If you have a look at the clouds, it's actually set a lot higher. And what you can actually set on the admission controller is things like this, like deny escalating exec, which you'd never want a pod to someone to exec in and then privilege escalate. I don't know why you would need that, well, at least in a production environment. Other one is make sure that they've got pod security policies, which you might want to check as well. But as you can see here, there's like, this is just 2 examples. If I go back to spinning up Istio on Kubernetes, and just look at the setup here, and go to Minikube. You can see the admission plugins that I've enabled here. So you can see like it's going to check to make sure that there's a limit range, that the namespace exists before it actually tries to run a command against it. Resource quota, so make sure that the service account is valid as well, default storage class. But mutating webhook emission is actually an interesting one. This is what Istio needs to make changes to the IP tables inside the pod for Envoy. And it's not insecure, but you just need to know what you're putting there as well. So if you go through the Kubernetes documentation, there's a whole heap of stuff you can put inside the admission controller. And then there's third-party plugins. So if you use something like Open Policy Agent, you can actually have a policy set to check the emission controller has got all these things before it executes stuff as well. But that's a bit more advanced. But there's, yeah, the emission controller is definitely, if you're into security, something that I would look at on the Kubernetes ecosystem. And as I said, like Open Policy Agent's a really good one to extend what emission controller can do. And then, of course, like we just talked about some of these configurations. You want to actually check that you've got those configurations in place. If you want to read the CIS benchmark, that's a real page turner of about 40 pages of dry reading of security controls on Kubernetes. But then you can check it with like Kubernetes just from Acro Security. That's a totally open source project. And what this allows you to do is like the CIS benchmark for Kubernetes is actually quite tough. Your business might not need to adhere to the whole of the CIS, but at least what you can do is say to an auditor, here's the CIS benchmark, here's a run of a kubench to say this is what passed, this is what failed, and then this is the business reasons why we haven't done like A, B, C in CIS. Because we actually don't need to be CIS, we just want to be benchmarked against a security practice. So don't, if you go, I want to do Kubernetes to CIS, you probably have a real hard time. It is like quite full on. But there could be other controls in CIS that you have that like make auditing or make your security team really happy. And as I said, you can check it. All this can be built into CD as well. So you can run automated tests nightly to make sure that this is all happening. And then you can give the CD pipeline as an audit trail to an auditor and say, hey, this is the intervals that we checked. Here's what's changed. Here's the remediation. And if you do that all through CD, like auditors love that stuff now. But now we're going to talk about, like, if you're an application developer, what you really care about. That was a bit more from the security team and also the SRE team. But this is pod security policies. Take note, because we're going to be doing a live demo, and this disclaimer, here's a treat for you. All the answers are in this particular part of the module. Because we're using Kubernetes doesn't mean that we're secure out of the box. Kubernetes has a lot of security that's really good that's turned off by default. And this sounds insane to me, right? But the Kubernetes project, if you go into a SIG group, says we only build the interfaces. It's up to the implementation of the person building that cluster to apply them. And when they say the person or persons, that could be a cloud, that could be a third party like Rancher, it could be anyone. So the Kubernetes ethos is like we build the interfaces for security, but then whoever implements the cluster that way will need to implement the security as well. And as you know, there's differences between AKS, GKE, and then there's more differences between those two and AWS's EKS. So yeah, I can see kind of where they're coming from, but as an end user, it's like confusing about what you have to toggle on and off. So pod security context is just actually tapping into the kernel and protecting the kernel, and it's just using like the kernel security, so AppArmor, SE Linux, or SecComp, which most developers don't really know what that is. But what you can do is there's like, you can actually start to automate some stuff if you know from the application developer's point of view, what processes run in the container, what file path it needs to write to. And just from those two things, if you protect the process running and make everything else read-only except for where the application needs to log or needs to write to, you actually have got a lot better segregation than you did prior, and we'll go through that. So the one thing about containers is they've actually been around for ages. So LXC is like 10 years old. The problem is like, why didn't people use containers prior to that? Is because it was like really difficult. And like the people who built LXC were kernel people, and they weren't actual developers. What Docker did is actually take all that and put a really nice like UI, UX experience over the top of it. So developers didn't actually have to really know about like C groups and a whole heap of lower level kernel things. They could just build a container and run it. And like a lot of people say, well, the Docker file is really bad because it's just bash, right? But how many developers know bash if you come from like a Linux background or even Windows now? Like you're not asking anyone to learn anything else. It's like really straightforward. It's easy to pick up. And if you have a look at another project, Rocket, that actually had like some good features in it, actually said like, well, we're going to use Go templating for our Docker files. So not only did you need to get people that knew containers, then you needed to get people that knew Go, or you had to learn Go, then to implement like Rocket containers. And if you have a look at what Docker did, they did something that wasn't as powerful, but the masses could use it. But yeah, what I want to get back to is that there's a whole heap of things in the Linux container and Linux kernel that is just what a container is. And it's been around for a long, long time. So containers are not new. I'm not going to go too far below the kernel in this particular talk. But you can see here that's where the security profiles applied. Because there's stuff that, like, there's Linux capabilities inside the kernel that you never want a container to load up. And if you don't put any security profile, they will be able to load those up. And that's where you start to have a look at like the CVEs and stuff that have come out. So a really good one about that is like, we'll talk about how many people heard the Alpine CVE this week? How many people think it's actually exploitable in the real world? Oh, yeah. I've seen a lot of like clickbait around that one this week, and I was like, there's not, yeah, it's not really that exploitable in the real world. One that was the run C vulnerability. And what that actually took advantage of is actually loading kernel level things and mounting a rogue version of run C as non-root into the container runtime, which could be in containerd or Docker itself. If you had a security profile around that and not allowed like things to run inside the container that are actually part of the container runtime, that would have helped you a lot. And another thing you should never do, and I see that people do this a lot, is run Docker in a production system. That is like horrible. Because what they do is they run Docker and they're like, oh, but the container running that's mounted at the Docker socket isn't root. And you're like, but the socket is root. And then underneath it, you got access to the whole runtime. So without setting up user namespaces and stuff, like don't do that. But basically what I wanted to show you here is the building blocks to security is just basic Linux security. And in theory, if we do our job right, it should be easier to protect a single process running in a container than it is to protect a VM. Now that's only because like you should have a whole lot less services running in a container. So you should have the least amount of services that the application needs. Like I spoke about before, if you're using a compiled language like Go or Rust, you run from scratch. So it's actually just the file system and the kernel. Then if you apply a security profile around that and you just have the binary running and you protect proc and everything else, you should have an easier time securing that than a VM. I know it's not always that easy. Like there's a migration path. People use put like fat containers with a lot of stuff in it and migrating from VMs to containers, and it's a gradual journey. But in theory, you should be able to get good separation pending a CV on a 0-day kernel vulnerability in containers. If I was running the team doing the security profiles, I would use setcom. That's because it just locks in at a lower version of the container and it runs on most Linux OSs. You've got libsetcom, and there's also a Go implementation of setcom. So if you're running any Go packages, you can just vendor in like Go libsetcom. There's 3 default policies that you can get in Kubernetes with no security at all. So no profile, no anything, just add them to your YAML file. The middle one is like going to be impossible to use almost on a real application because like it makes the whole root file system read-only. So unless you've got a static binary that's serving one process and not writing or logging or doing anything, that's not going to work. But what you can do with that is it starts to get you in the mindset of writing a policy around. So you can write a setcom policy around file system fairly straightforward. So like I did a talk at Container Camp 2 years ago where that was when Dirty Cow was around, and I was actually able to get into the Nginx container, use Dirty Cow to privilege escalate by firing something up in the temp directory. And then by applying a seccomp policy where I was only allowing Nginx to write in the Nginx folder and only allowing the Nginx process to run, I couldn't privilege escalate anymore because the binary wasn't able to get into the actual pod. So you can do a lot of cool things around that. But if you're testing and you want to have a look and play around with read-only root file system, it's fun to play around with, kind of. Run as a user, people ask me a question, like I just did a whole heap of training over at DockerCon about Kubernetes security. They're like, shouldn't that be in the Docker file? And I'm like, 100% it should be. But if you've got developers that are not doing that, you can like hit it with a sledgehammer and make Kubernetes run it as a non-root user. And you can define the user it is. Now that will break stuff if it needs root. Nginx will break. Apache will break. So this is not like a clean way to do it. But if you're trying to like as the last line of protection in the CD process, you can change run as user. Allow privilege escalation. I ask the question in every talk I do, how many people think it's okay for a pod to privilege escalate in a production environment? Is there any need for that ever to happen? So one guy has told me Ansible needs it. And I'm like, maybe not run Ansible in your pod then. No, I'm surprised still that this is turned on by default. So by default, Kubernetes will allow you to privilege escalate inside a pod. That's pretty bad. But the flag's there to turn off. Okay, so demo time. So let's have a look. I've got my company website here. It's a good company website. My 4-year-old picked that. Oh, he's 5. He turned 5 months old. I've got to say that. He picked that GIF. He really likes it. Now I'm going to show you a Docker file, and besides I haven't updated this for the Alpine CVE, so if you yell at the Alpine CVE, you'll kind of be wrong, but right as well. I've just got, this is the Golang that it's doing it, some of my best Golang coding there, as you can see. Nothing looks too malicious there. It's just serving a static index file. Not much happening there. The Docker file, this is the important thing. So you can see we're going from Golang. We're using Alpine, so we're not using a lot of static binaries. We're using multi-stage build, so we're just building a static binary. Then we're going to Alpine 3.8, which is probably got a vulnerability in it now. We're just putting Vim in there because we need it for the demo. But it looks pretty good. Like, there doesn't look anything too suspicious about this Docker file, does it? Can anyone pick out anything that's... No? Yes? Okay, cool. So that's our application. And if we go over to Docker Hub, this might not work now because there might be a CVE against the... against Alpine. How many people know you can check security scans on Docker Hubs on the tags as well before you even get started? So tag. Oh. Why isn't the scans not working now? Aha, there we go. Oh, so you can see 3.4. So we're using 3.8. Okay, cool. They haven't put the CVE up against it. Laptop's just running a bit slow. But you can see there all the vulnerable packages and things like that. If you go to CentOS, there's like 27 critical vulnerabilities in it straight out of the box before you put any application code in. Now, they might not be showstoppers. Some of them are glibc. Some of them are really hard to exploit. But at least you should know that you're doing that in your environment before you get there. This is taking too long. So anyway, this one's got like a busy box, like medium vulnerability. So looks okay. So if, as a developer, I'm looking at this, I'm going, that's okay. So what we'll do now is I'll just make sure, yeah, I'm on the right. So I'll just, KP is me going kube control get pods lazily because I type it so many times a day. Every time I do a talk and people say, what's KP? Is that a new thing? I'm like, no, it's just my lazy bash alias. So I've got my pod here. This is my pod. So if I go kube, we're just going to use an exec to simulate an attack because I haven't had time to write one. Well, Google, IT. Oh yeah, exec. Okay, cool. So we're simulated an attack. We're into the container now. And straight away, if I get shell access, I go, who am I? And I'm root. So one of the things that I didn't do in my Docker file is I didn't specify the user that it's running as. So what can I do now? So if I go vim, because we installed the dev tool, which seemed fairly harmless, static index, and I'll just go down here. Go back here and just get my new GIF. And now I'll go to my company website. Oh. How was I able to do that? So, actually, I'll show you the deployment as well, because that's, we looked at the, so that's the deployment there. So there's nothing that looks too sinister. The Docker file looked good. We're using Alpine Linux. The compiled binary looked small, but why was I able to change the index.html file? Now, the answer was back up before. The reason I was able to do that was because there was no pod security policy applied to the pod at all. So it was just open. My phone, the internet's running slow. So it was just open. So there's no pod security policy applied at all. So because I didn't specify a user, I was root. Now that would have been like really disastrous if I had like a mount and bind a mount into the OS underneath, because the UID would have matched, and then I would have, whatever mount was there, I would have been able to go out. And why is this taking so long? There we go. So I didn't apply any pod security policy. So out of default, on a deployment in Kubernetes, there was no security controls around that deployment. And most developers don't know that, or nor do they understand that. So how could we have mitigated that? Basically, what we would have done is we would have applied a seccomp profile to say that the index.html file was read-only. That would have fixed it straight away, because like that's a static file. Again, we would have said we won't run as root. We could have run as user 1000. So if we have a look here, I'll actually show you what the answer here. So what we could have done is we could have done a deployment like this, and we could have added these lines and just added security context, run as user 1000, read-only root file system true. Now this application has been is being made for this lab to allow read-only root file system without me having to explain a full seccomp profile to people, because it is the beginners. But imagine that that line in a production environment was your AppArmor, SE Linux, or seccomp profile. And it was just a read-only file system for the index.html file. And allow privilege escalation false. The reason you need all three of these is because if you run as user 1000, you can actually privilege escalate. Actually, on Alpine, it's really hard to do, but you can spawn another process. If you just use user 1000 and don't allow privilege escalation false, you can actually spawn a process as a root user if you can work out how to. So you needed all three of those things. So that's very basic, a thing to put in a CD profile and check to make sure your deployments have pod security policy. Pod security policy is probably the most important thing that you need to know as a developer. And as I said, it's not hard. So if you have a Docker file and you have the user and you can do some things like that, you can actually have some custom tooling to to generate a seccomp profile for you. This might be a really rudimentary one with just like read-only file system, where the file system should be read-only, but it's better than having nothing at all, as you just saw. And with that, I've got 3 minutes left, so I'll just jump straight to questions. Oh, actually, I'll go to automate, and then with questions. This is really quick. So everything that we spoke about today is defined in YAML, which is, whoop, I'm in internet troubles today. Is defined in YAML, which is, some people say is good, and some people say is bad. But what it does mean is you can use GitOps workflow, and you can have change process, and you can have a CD process doing all of this. So when you go and you have an auditor, you can go, on this date, we had this vulnerability, on this date, we've done this is a security policy we applied. You can see when security policy were changed. You can actually add the security team to approve PRs. Now, for some security teams, that sounds really, really far off in the distance, and they don't want to do that. But for the teams that I've seen implement this, it's actually really, really good for their auditing point of view. Any of the stuff that I told today needs no extra tooling. It can just be built into pipeline, whatever pipeline you do. And it's like you can literally write a bash script just to check for like pod security context is there. If not, fail the build. All right, thank you everyone for coming out, and hopefully you have a good conference.